Hello, everybody. Here are the solutions to our quiz on learning targets 1 through 3 in Unit 2. The directions are find the whole of this function, show or explain all your work. So just showing your work is really sufficient here. So to find the whole, this is a rational function. A whole is a point of discontinuity, and points of discontinuity for rational functions always occur for x values that would make you divide by 0. So let's factor the denominator, denominator. And that's an easy one. That's x plus 7 times x minus 2. So there are 2 points of discontinuity. They are when x equals -7 and when x equals 2. So what that means is if you were to graph this function, it would be discontinuous at 2 points exactly, at 2 and only 2 points. Once when x equals -7 and once when x equals 2. Well, which of those is a removable point of discontinuity? You have to factor the numerator. And the numerator has a, what's it called? A GCF of 3. 51 divided by 3 is still 17, I believe. And 210 divided by 3, well, 21 divided by 3 is 7. So 210 must be 70. And 2 numbers that multiply to 70 and add to 17 are 10 and 7. So we've got our numerator. This is what's in top. And our denominator, this is what's in bottom. Notice the x plus 7 cancels out. It gets removed. So that tells me that -7 is the whole. That is the removable point of discontinuity. What about x equals 2, you may ask? What is that? That is a vertical asymptote. So I have to find the whole. Well, I know the whole exists when x equals -7, but what about y? What's the y value? You plug in -7 into the function after you remove the common factor. So the numerator would just have, so the reduced version, I don't know what the math word is. In the numerator, you would have 3 times x plus 10. The denominator would just have, I forgot already, x plus 2, I believe. No, x minus 2. X minus 2. And you would plug in -3 into this. So -3 plus 10. Look how good of a job I'm doing by showing my work. Why plug in -3, you ask? -7. Where does that come from? -7. -7 is the whole, the removable point of discontinuity. Minus 2, and that equals 3 times 3 in the numerator. The denominator is -9. And that equals 9 divided by -9, which equals -1. So the whole is at -7, -1. Full credit. There's the final answer. And everything above it is the work that supports it. Next. Similar question. Find the points of discontinuity that are vertical asymptotes. So a vertical asymptote occurs at a point of discontinuity, and a point of discontinuity is an x value that would result in division by 0. So you're only focusing on the denominator for points of discontinuity, denominator. That factors, well, x plus 3 is already factored. X squared minus 25 is the very, very famous difference of squares. So there are the factors of the denominator. So points of discontinuity would be -3, +5, and -5. There are 3 points of discontinuity. But I'm asked which of those points of discontinuity are vertical asymptotes. It depends on what gets removed. So for that, I have to investigate the numerator. That factors into x minus 8 times x plus 5, I believe. Yes, it does. So the numerator and the denominator, of course, I hope we can see that this in the denominator, see if I could be clever. Probably not worth the time it takes to do this. But both of those numerator divided by this, they both have a common factor of x plus 5, so that gets removed. So that means negative 5 is a whole, which means the other two are vertical asymptotes. And make sure, if this sounds like such a simple instruction, but make sure you are answering the question that is being asked, especially on SAT. There's lots of things you can mine out of a question, but only answer the question that is being asked. And we are asked, what are the vertical asymptotes? So there are two. X equals negative 3 and x equals 5 are vertical, you got it, asymptotes. Full credit. Next. Aha, and behavior. So here, this end behavior, remember this is like it's all about those dominant terms, the dominant terms. So in the numerator, I've got 2x to the fourth divided by 13x to the third. There are other things contributing to the y value, but these two are the dominant terms for the numerator and the denominator. So when x gets really, really big, or when x gets really, really small, these two things dominate. It's really just up to these two. Well, this simplifies into 2x divided by 13. So 2x divided by 13. So in other words, when x gets really, really big, or when x gets really, really small, this whole rational function is essentially just equaling 2x divided by 13. Well, when x gets big, 2x divided by 13 gets big. So that means b equals positive infinity, because b is the y value that is being approached when x gets really big. And when x gets small, in other words, negative infinity, what happens to 2x divided by 13? 2 times negative a million divided by 13 is a negative number. In other words, a really small number. So a is negative infinity. So when x gets small, so does the y value. When x gets big, so does the y value. And it's justified by my work here. Next. Oh, yeah. Another removable point of discontinuity. I hope you did that Delta Math assignment. Removable point of discontinuity. So similar problem, numerator and denominator. Let's see if I can do this a little bit more efficiently. Here is the numerator. That is being divided by the denominator, which is x minus 3 times x plus 2. And the x plus 2's cancel out. So that means x equals negative 2 is the removable point. But you have to find, it's a reminder here, we're finding the x and the y. So that's the x. How do I find the y? Well, after you cancel out these factors, after you remove them, what you are left with, the reduced version, is x minus 2 divided by x minus 3. And you simply plug in negative 2 into that. So plug in x equals negative 2. So I've got negative 2 minus 2 divided by negative 2 minus 3, which equals negative 4 divided by negative 5, which equals 4/5. So the whole is at negative 2, comma, 4/5. Next, in behavior. This is not a rational function. This is a polynomial. And polynomials are continuous. They're always continuous. And they just go on forever. The domain is all real, and the end behavior, it either goes up to infinity or it goes down to infinity. Always for polynomials, always. It'll never approach a real number. It'll either go up to positive infinity or negative infinity. And it depends on a couple of things. The degree. What is the degree of this polynomial? Well, 2 times x to the first. So it's a degree 1. But then when I multiply this, it becomes a degree 2. And then when I multiply this, notice it's being squared. So a degree 2 will now become a degree 4. And then when you multiply this, notice it's being cubed. So a degree 4 times this will become a degree 7. Remember, when you're multiplying, you add the exponents. So the degree is 7, which is odd. So the end behavior changes. You're going to have one that's going to positive infinity and one side that's going to negative infinity. But which is which? It all depends on the leading coefficient. The leading coefficient here, if you were to multiply all this out, you don't have to multiply it out. That would be very, very time consuming. You could just kind of look ahead. First of all, this 3x plus 8, if it gets cubed, that 3x is going to become 27x to the third. 27x to the third. When that gets multiplied by this, realize this is x squared. So 27x cubed times x squared is 27x to the fifth. And when that gets multiplied by this, it's 27 times x to the sixth. And when that gets multiplied by negative 2x, you really don't need to know what 27 times negative 2 is. You just need to know that it's going to be a negative, and then x to the seventh. It's negative 54, x to the seventh, but the key thing is that it is negative. Why does that even matter? Because that is the dominant term. The dominant term is negative 54 x to the seventh. And then it's plus or minus the rest of that polynomial, whatever it is, if you multiply it all out. But the term that dominates all other terms is this one. And it really matters when x is really big or when x is really small. So when x gets big, like a million or a billion to the seventh power is huge, huge, huge number. But when you multiply that huge, huge number by a negative 54, well, a positive times a negative is a negative. So that means y gets really, really small. So as x gets big, the y value approaches negative infinity. That's the answer to B. And since it's an odd degree, I don't even have to continue thinking. The other thing has got to change because odd degree changes on both sides. So if it goes down to the right, then facing to the left, it must go up. Next. What's asked here? Identify the relative maximums and submit your answer like this. Well, looking at this, this is a relative minimum. That's not what it's asking. Here's a relative maximum. The relative maximum is 0 when x is negative 3. And here's another one right here. The relative maximum is also 0.501 when x is 0.38. So there are two of them. There is a relative maximum of 0 when x equals negative 3. And this is the advantage of typing instead of handwriting. You could just do this. And there's also a relative maximum of 0.501 when x is 0.38. And just double check, was that all that was being asked? Yes. Next. Identify all increasing intervals, decreasing intervals, and constant intervals. Must use interval notation. Well, increasing intervals are when the y values are going up as you read from left to right. And there's only one. There's only this one. This is a constant interval, so is this. And this is a decreasing interval. So increasing interval, let's see here. It begins when x is negative infinity and all the way till when x is positive 1. I just realized this is a bad question because incidentally the y is also positive 1, but you're communicating as x values. You almost always communicate in x values, the independent variable. So when is this graph increasing? Well, when x is negative infinity all the way until x equals 1. So negative infinity, comma 1, decreasing interval, only 1. Right here. What x values make the function go down? Well, the x beginning when x is 5 and then continuing on until when x is 7. So that interval. And you may think that the small interval, well, in a way you're right, but just realize this is mind-blowing. There are literally an infinite amount of numbers between 5 and 7. There are an infinite amount of rational numbers between 5 and 7, an infinite amount of irrational numbers, an infinite amount of fractions. It's just boggling. Constant intervals, because there are two. There's a constant interval here between x equaling 1 and x equaling 5, and then also here when x equals 7 and on to infinity. So this is between 1 and 5, union 7 to infinity. Just double check my work, between 1 and 5, and then from 7 to infinity. Yes, that's what I wrote. Next. More and behavior. Again, the dominant, this is a rational function, so you're looking for the dominant term on the numerator and the denominator. And looky here, they're both x to the fourth, so they both rise at the same rate, almost. The numerator is 3 times that number, where the denominator is 5 times the same number. So that settles down to a ratio of 3 to 5. So the answer is just simply 3/5. It goes to 3, it approaches 3/5 on both the left side and the right side. Remember, when the degrees are the same, it doesn't go to infinity or negative infinity. It just settles down to the ratio of the leading coefficients. Oh, and that was it. I hope that was as good for you as it was for me. Please let me know if you have any questions, and I look forward to grading it.